This video will be useful for any beginner welder that is interested in enhancing consistency and productivity through the use of muscle memory, weld tempo, and timing. In simple terms, this video will demonstrate how to time your personal rate of travel and how to transfer that rate of travel to any mechanical device like positioners, rollers, carriages, etc. By using this timing technique, over time, you will develop an intuitive feel for dialing in your personal rate of travel to any positioner or roller, etc. by the use of muscle memory through practice over time. In this first demonstration, we'll be timing Flux-Core NR211 035 wire with no gas, also known as inner shield. Running parameters of 17.1 volts and 109 for wire feed speed. In this Flux-Core demonstration, we're timing the rate of travel to 60 seconds, which equals to 1 minute. In this segment, we're running a stringer bead and dragging it with no oscillation or weave. For demonstrative purposes and simple explanation, the parameters were set to cover the 8-inch plate in 60 seconds, which equals to 8 inches per minute in this segment, as demonstrated. As we approach the 1 minute mark on both of our stopwatches, I will display a screenshot of the start and both the second before and the 1 minute mark that displays the 8 inches per minute. In this screenshot, the stopwatch is at 0, now at 59 seconds. And last, at the 1 minute mark, where you can see the edge of the plate is bright orange, indicating the end of the 60 seconds, which equals to 8 inches per minute with weld parameters of 17.1 volts and 109 for wire feed speed. Now for the MIG demonstration, we'll be using 70S6 035 solid wire, 7525 or C25 shielding gas, 16.3 volts, and 200 wire feed speed for weld parameters. For this MIG demonstration, we increase the wire feed speed to 200, also running a side-to-side oscillation while dragging the bead. In comparison to the Flux-Core demonstration, the MIG rate of travel seems to be moving faster relative to the Flux-Core demonstration. So what's causing the increase in momentum? It's the side-to-side oscillation and increase in wire feed speed that creates the illusion of faster rate of travel. Near to approaching the 1 minute mark and the end of the 60-second timing cycle, we'll see again the edge of the plate is bright orange, marking 8 inches per minute as the rate of travel. As demonstrated in prior videos, you can also time your rate of travel in 30 seconds instead of 60 seconds. As mentioned before about the difference between Flux-Core and MIG in momentum and the cause of that fluctuation between these two processes is being displayed in this screenshot. For the last and final demonstration, we'll be timing the rate of travel with TIG. So this process depends on the welder's hand and eye coordination and how skilled the welder is in feeding the rod. Also, we're running a stringer bead with no oscillation. The TIG process compared to Flux-Core and MIG looks a lot slower in momentum. It also depends on the tungsten diameter and rod size in use. That will dictate a faster or slower rate of travel. The TIG rate of travel for this demonstration was timed at 6.5 inches per minute. So the 1 minute mark did not use the whole 8-inch plate, instead falling short 1.5 inches, which gives you a result of 6.5 inches per minute. This screenshot displays the 1 minute mark along with the 6.5 inches per minute marked by the downward arrow pointing at the exact time 1 minute was displayed on the stopwatch. So this brings me to the video's conclusion on how to transfer your rate of travel in inches per minute to a positioner, roller, or carriage. So both Flux-Core and MIG were timed at 8 inches per minute, and TIG was timed at 6.5 inches per minute. Now, to transfer the 8 or 6.5 inches per minute to a positioner or roller, you will have to time the part you're going to be welding on, whether it's a circumferential weld like pipe or a longitudinal weld like a seam on a plate. Once you match the positioner, roller, or carriage's travel speed to your rate of travel, you have dialed in your frame of reference, which gives you the ability to tweak your criteria or quality values like weld size and visual presentation, along with practical measurements like weld parameters and consistent productivity, and most of all, to decrease or increase your efficiency with a repetitive outcome.